Let's have a look at a problem that comes up all the time in trigonometry, and that is finding the height of something that's in the air. Now, it could be a bird, a plane, or Superman, or in this case, we're going to find the height of a kite. So let's read the practice problem we've been given. I'll show you how to solve it, and then I'll give you an example later. Chai is flying his kite. The kite string is 40 meters long. The angle of elevation the string makes with the horizontal is 26 degrees. What is the height of the kite? And the question also gives us a very nice looking diagram of Chai flying his kite on a nice breezy day. Now, to solve this, the first thing we need to do when we're solving word problems in trigonometry is to figure out which tool in our toolbox is best for the problem. I know three tools I can use: SOHCAHTOA, the sine law, and the cosine law. Now, which one's best? Well, it looks like I've got a 90-degree triangle here. When I see that, I immediately think about using SOHCAHTOA because it's the easiest way, generally, to solve for 90-degree triangles. If I didn't have a 90-degree triangle, I'd probably look more towards sine law or cosine law. But I'm going to go ahead and use SOHCAHTOA for this. So the first thing I want to do is label the sides of my triangle: opposite, adjacent, and hypotenuse, and that's step one. The first side I'll label is the opposite, and that's right here because it's the one line on the triangle that isn't meeting in this corner. You see, this line meets right there, and this horizontal piece meets right there as well. So this angle is sort of facing this side. That's the opposite, which makes this piece the adjacent, or the horizontal part. And finally, that just leaves my hypotenuse for the triangle, and it's the line pointed from his hand to the kite. There we go. Now that I have all three sides labeled, I can go ahead and set up a trigonometry ratio, and that's the next step. SOHCAHTOA. Sine is opposite over hypotenuse, cos is adjacent over hypotenuse, and tan is opposite over adjacent. So which one of these three do I use? Well, I'm looking for this piece right here, which I'm going to go ahead and give a label. I'm going to call it x, since I don't know it, and that's what I'm trying to solve for. So which one of these trig ratios would work best? Well, I'm thinking opposite over hypotenuse would probably work best since the hypotenuse is given. And sine is opposite over hypotenuse. So I'm going to set up a ratio using sine, which looks like this. Sine of the angle given, which is 26 degrees, is equal to opposite, we don't know. It's the variable called x, divided by the hypotenuse, which we do know. It's 40 meters. And there we go. I've set up a ratio. The next thing I want to do is isolate for this piece right here, the x, which means I have to cross multiply. So I'm going to add a 1 here just to make it easier on myself for cross multiplying. And I know for cross multiplying, I do 40 times the sine of 26, and it's equal to 1 times x. If you're not sure about how I did this, check out an earlier clip on cross multiplication. So let's write 40 times the sine of 26, and it's equal to 1 times x, which is just x. There we go. I've got x isolated all by itself. This piece will involve using my scientific calculator. So let's bring that up. And I'll just type in what I see there. 40 times the sine, which is this button right here, sine, the angle is 26, and then I hit enter. And there I go. I get 17.5. I'll say x is equal to 17.5 meters. And that is the height of my triangle. Let's add a concluding statement. The concluding statement says, therefore, the height of the kite is 17.5 meters. Now let's see how you do with a problem of your own. I'll present the problem you can try it out on paper, and I'll present the solution when you're ready. So it reads like this. Tim is flying his kite. The kite string is 20 meters long. The angle of elevation the string makes with the horizontal is 30 degrees. What is the height of the kite? And just like before, you've got a nice diagram of Tim flying his kite. All right, so good luck. The height of Tim's kite is 10 meters. We found that by recognizing we have a 90-degree triangle in this problem, so we can use SOHCAHTOA, meaning we have to label adjacent, opposite, and hypotenuse sides. And we created a variable called x for this unknown height. Then we used the sine ratio. Sine 30 equals x over 20, opposite over hypotenuse. And then it's just a matter of cross-multiplying to arrive at this line right here, where x is isolated. Then we punched this in to our calculator and arrived at our final answer. X equals 10 meters.